Well, welcome everyone to today's webinar. My name is Jamie Hale. I'm Commore's technical service. I take a lot of the phone tech calls. I go out into the field on retrofits, new equipment, that type of stuff. My first 30 years I spent out in the field as a technician. And for the last 20 years, I've been doing tech support on various refrigerants. I went through the R12 phase out, the 22 phase out, and now we're moving into a new generation of refrigerants, the A2L refrigerants. That's what we'll be talking about today. We'll be talking about installation and servicing. There's a chat box that you can type questions in, and then at the end of the session, we'll answer all questions. There's 7 of us on the call now, so if you have a question during the webinar, you could unmute yourself and ask the question, because I don't think we'll have that much feedback then. All right, so the course outline, we'll talk about charging procedures, of course. Filter dryers, we'll talk about liquid and suction applications. I'll talk about the proper way to braze in components with dry nitrogen, compressor superheat, subcooling, evaporator superheat, evaporator temperature split, or better known as delta T, temperature pressure charts and pressure temperature charts, the difference between the two, system evacuation, and then at the end, I'll go through some troubleshooting slides. So the new equipment, just like all new equipment, will come with a service manual. And it is critical that the technician understands the proper way to install this equipment, servicing some of the components, because they will be a little different than components that they're used to seeing in systems. Most of these air conditioning systems will have sensors on them to sense the refrigerant, because it is a A2L refrigerant. They may or may not need PM, preventive maintenance, on those sensors. It will just depend on equipment. They really need to understand the difference between an A2L refrigerant and an A1 refrigerant like 410A that they're used to using today. They should always review the safety data sheet. Each chemical has a safety data sheet, so they need to review that. Luckily enough now, if they haven't reviewed a safety data sheet and they're used to a MSDS, safety data sheets are much easier to read today than the MSDS. They're all sectioned. Each section is the same on each SDS now, so it's much easier to understand an SDS over an MSDS. Just like any refrigerant, make sure that proper ventilation, especially if they're working in confined spaces. A lot of these units will be in confined spaces, especially the air handler side. So never go into a confined space by yourself. Always have a partner when you're working with any refrigerant, whether it be a A1 or an A2L refrigerant. Recover the refrigerant in a properly rated and marked cylinder. The refrigerants that they'll be using, the A2L refrigerants that they'll be using in air conditioning applications, will need the 400 PSI cylinders, just like the 410A cylinder. Pressures are very close to 410A on the air conditioning side of the A2L refrigerants. So make sure they are properly marking the cylinder after recovery, what refrigerant they have recovered. That way There will be no mixing of refrigerants. You do not want to mix any refrigerants, especially a A2L into an A1 system. Always purge with dry nitrogen. We'll be talking about dry nitrogen quite a bit. It will be in the instruction manual on how the manufacturer wants that system to be brazed, but the technician will need to purge any component, any line set, anytime they put a torch on that system. They will have to have dry nitrogen flowing through the piping or component as they braze it in. And this shouldn't be anything new. This should have been done with any other refrigerant. Displaces oxygen, it makes it a lot better joint, and it's much safer. If you notice a flame, increase in size, color, that type of stuff, always turn the torch off, reventilate whatever you're brazing. Make sure all of that oxygen is displaced before you put the torch back on. System must be free of any refrigerants, so again, purge is critical. Evacuate the system. Again, different manufacturers want different micron levels. Industry standards is 500 microns, but as time goes on, some manufacturers have determined that they want it as low as 200 microns. So again, that will be all in the instruction manual, and they have the reasons why they want it down to 200. So it really needs to be pulled down to 200 microns if that piece of equipment they're installing wants it at 200 microns. Filter dryers, again, this is nothing new here. Any system out there should have a liquid line filter dryer on it. Not all systems come with filter dryers new, so make sure before they leave wherever they're purchasing the equipment from that they pick up a filter dryer if that system does not have one from the factory. Again, only braze with dry nitrogen. Make sure that everyone understands that dry nitrogen needs to be purged through these components, through the tubing, before a torch is put on the system. So, weigh in the charge. Again, this isn't anything new. Again, it will be in the instruction manual on line set lengths. So years ago, it used to be 25-foot line set for the condensing unit before you had to add refrigerant. Now it's around 15 foot before you have to add refrigerant. And the jury's kind of still out on the new equipment, what it will be. But bottom line is, it will be in the instruction manual. They will have a chart in there saying X amount of additional piping. You need to add X amount of refrigerant. So again, that's why it's very important to read and understand the charging guidelines. Anytime that you introduce refrigerant to the system, whether it be topping it off, whether it be initially charging a system if you had to replace a component, that cylinder has to be inverted. Liquid refrigerant has to leave that cylinder. If the technician vapor charges, it will fractionate the refrigerant in the cylinder and fractionate the refrigerant in the system. Now, again, this should have been done with 410A, so it shouldn't be anything new. But just as a reminder, make sure that everybody understands that the refrigerant has to leave the cylinder in the liquid phase. And always optimize the system by either superheat, subcooling, pressures. And again, this will depend on manufacturer. And again, it will be in the instruction manual. And for some of the guys on the call today probably don't know the term beer can cold. Basically, that is a technician out there charging the system and putting his hands on the suction line or the line coming back to the compressor off the evaporator. And if it's cold, it's good to go. And that has never been the proper way to charge any system. And especially with these new systems, higher SEERs, we definitely want these systems to be charged properly. You know, overcharged, undercharged, you will use energy both ways, so it needs to be properly charged. It needs to be charged as the manufacturer has specified it in the instruction manual. All right, so let's move over to temperature pressure charts. We'll talk about a temperature pressure chart first. Now, why I bring this up is typically air conditioning technicians do not use temperature pressure charts or pressure temperature charts. They typically use their gauge set because it has 410A, it has R22 on the gauge, the temperatures. And they've just always used that. Has it always been as accurate as it could have been? No. That's why a temperature pressure chart or a pressure temperature chart should be used. It's more accurate, and more than likely, if they're using analog gauges, the refrigerant will not be on the gauges anyway. So they really need to get familiar with how to read these charts. It's not rocket science by any means, but they need to understand how to read the charts. So a temperature pressure chart is on the left, and the reason they call that a temperature pressure chart is because the temperature is on the left-hand column here, and the pressures are on the right-hand column, depending on what refrigerant they're using. So a pressure temperature chart, the pressure is on the left-hand column, and the temperature is on the right-hand column, depending on what refrigerant. So all 400 series refrigerants will have a dew pressure and a bubble pressure. And it is critical that the technician understands that he needs to use, or they need to use, the dew pressures to calculate superheat and the bubble pressures to calculate subcooling. If they vice versa use the wrong one, the superheat, the subcooling will not be accurate. So it is very critical. Now on these two charts here, as you can see, the dew pressures are in the lower temperatures for superheat and in the higher temperatures for subcooling. But they may come across pressure temperature charts or temperature pressure charts that have bubble and dew columns side by side. That's where it gets confusing. So they really need to understand that bubble pressures are for subcooling and dew pressures are for superheat. Now you're going to get the question, can I use my gauge set? Yes. If you have a 410A rated gauge set, you can use it, which this is down here, tells you the refrigerants. Inside the dial here is the temperature of the refrigerants, depending on manufacturer of the gauge set, depending on manufacturer of the gauge itself, would have different refrigerants in it. On the refrigeration side, you might deal with 5 or 6 different refrigerants. So that's why there's different gauge sets for different applications. But they can use their analog gauges, and they will read pressure. They don't read the inside dial here that has temperatures of the refrigerant. So the pressure we'll use, for example, is 150. So on your pressure temperature chart, 150 pressure equals these temperatures depending on what refrigerant they have in the system. So for 454B, which will be a very common refrigerant that you'll be dealing with, for example, 410A pressure is 52, 454B pressure is 58. So you can see there's a difference in the pressure of the refrigerants. So that's why it's very critical to use a pressure temperature chart rather than the temperatures on the dial of the gauges. They cannot use your 410A temperatures to charge a 454B system. If they have digital gauges, that will be in the program. It will have the pressures, the temperatures in the program. Now, not all digital gauges will have 454B, for example, in it. So if that's the case, they can take it back to the supply house and have it reprogrammed for the new refrigerants. It just depends on the age of the digital gauge set. So this is more on the service side. You know, these systems, you know, after installed, of course, they'll need service, whether they'll have leaks, whether they'll, you know, just different reasons. But yes, they will. The technician will have to put a torch on it every once in a while. And again, they need to purge the system before they put that torch on there. You know, leaks in a coil, leaks on a tubing, expansion valve change out, filter dryer change out. If you notice here on this filter dryer is even in the wrong way. It's in backwards. So, you know, as the customer calls, the system's not working properly, the technician gets there, realizes that someone has installed that filter dryer backwards. They'll need to replace that filter dryer. And before they put the torch on there, they'll need to purge that line set, that filter dryer with dry nitrogen. And again, you'll get a much better braze, leak-free braze. And it's just a very good idea to always purge any component, any line set before you put a torch on. This image here, this technician is holding a regulator that is designed for purging. All you need is 1 to 2 pounds of pressure going through the tubing or going through the component to get all the oxygen out. So they do make regulators for this application. Filter dryers. First, we'll talk about liquid line filter dryers. Again, as I mentioned in the beginning, if the new piece of equipment doesn't come with a filter dryer, make sure that the technician gets one before he starts to install a piece of equipment. Anytime that equipment is serviced, anytime that equipment is opened up to atmosphere, a new filter dryer needs to be replaced. You know, filter dryers are in systems to trap moisture, to trap contaminants, and anytime that system is opened, you will introduce moisture, and depending on what the failure was, what component failure was, you could have contaminants floating around in the system. They never should unbraze a joint, whether it be a filter dryer, whether it be a compressor, any component should always be cut out. You don't want to put a torch on a component, especially a filter dryer that has high moisture levels in it. Once you put that torch on there, that moisture is going to go back into the system. So it's always best to cut out the component. Again, after the component is replaced, the system will need to be pulled down to the micron level that the manufacturer wants it to be. For example, a residential unit, you let it blank off the vacuum pump, let it sit there for 20 minutes or so. If the micron level rises and levels off, that means you're leak free, but you still have moisture in the system, so you need to change the oil in the pump and re-evacuate again. But if it holds steady for 20 minutes or so, you know you're leak free and you know that moisture levels are low, and the system can be recharged and started again. Now, some of these systems, Suction filters will not come with the systems. Suction filters do not need to be installed initially, but if the system had a compressor burnout, that's when a suction filter will need to be installed. Now, suction filters are not designed to stay in the system long term. They are designed to clean the system up. And after the cleanup, they need to be taken out. Now, on an air conditioning application, let's say you had a burnout, you installed a suction line filter dryer, a liquid line filter dryer, got the system up and running. That suction filter needs to be monitored the first hour of runtime. All contaminants will come back to that very quickly. So when you exceed that 3-pound pressure drop across that suction filter, it needs to be replaced again. And then monitor it after the system's cleaned up, cut out the suction filter, put a tubing in, and you'll be good to go. So what will happen if that suction filter is left in the system long term and you exceed that 3 pounds of pressure drop across it? You will burn up that compressor. Compressors are cooled by refrigerant coming back to it. So if you have a pressure drop across the suction filter or the suction filter is restricted, you're not getting enough cool vapor back to the compressor, and it will prematurely burn up. This isn't something that's going to happen overnight. You know, compressors are pretty tough. It may take a month, it may take a year, but bottom line is you're not going to get the life out of that compressor that it was designed for. So suction filters need to be monitored. They need to be taken out after the system is cleaned up. And again, you need to purge with dry nitrogen. You need to pull that system back down to 500 to 200 microns, depending on manufacturer. Again, let it set for 20 minutes. If you don't have any leaks, if it doesn't rise, you're okay. So I'll talk a little bit about compressor superheat now. Typically, these new systems will come with expansion valves on the evaporator side, but manufacturers, they get pretty creative. So to meet SEER ratings, they may or may not be able to use pistons. Just depends on manufacturer. But if these systems have pistons in it, more than likely it will need to be charged by compressor superheat. Now, it is critical that the technician uses the right piston for the refrigerant. So depending on what that system refrigerant design is, would depend on what orifice needs to be put in that system. So make sure that they are using the right piston for the refrigerant in the system. So how do you check compressor superheat? Well, you'll need some tools. If they've been charging R22, R410A systems with pistons in the past, hopefully they have a digital cyclometer or a sling cyclometer now. If they don't, they need to purchase one. Both are very good, both are very accurate, both are tools, so both of them need to be taken care of, and they'll last a long time. So you get the indoor wet bulb temperature. It needs to be as close as it can to the air handler. If you can get it inside by the air handler, that's the best place, but typically if they get it the closest return vent to the air handler, that's okay. The example here, we're going to use 60-degree wet bulb temperature, and then they will need to get a outdoor temperature. And when I say outdoor temperature, I don't mean their cell phone. They need to get the temperature entering the condensing unit, the outdoor condensing unit. If there are multiple condensing units in the space, this is a good time to check to make sure they're not getting recirculated air from other condensing units. So Example, if it's, around 80 degrees ambient and they're getting 100-degree readings entering the condenser, more than likely they're recirculating from another condensing unit or from this condensing unit. So that's a good test there. But normally, just a good temperature entering that condensing unit is okay. So on this example, we're going to use an 80-degree outdoor air temperature or dry bulb temperature. So this is a generic superheat chart. They can download this off of Google, or if they're using the R22 or 410A slide charts, they can still use that slide chart to get the superheat. They just can't use that slide chart for pressures with the refrigerant that is in the new piece of equipment. So remember, we have an 80-degree dry bulb and a 60-degree wet bulb. That intersects at 8-degree target superheat. So as you can see here, superheat can vary from 33 to 5. So that's why it's very critical to get the target superheat to properly charge the system. So we're shooting for 8 degrees of superheat. And where do they get the measurements from? They get their temperature underneath the insulation, and they get their pressure at the service valve on the suction side. So again, they need to get the pressure temperature chart. And the example we'll use is 107 pressure on the gauges. Go down to 107 pressure, go to the left on the temperature pressure chart, and that gives you 40-degree refrigerant temperature or saturated gas temperature. Underneath the insulation, we were reading 55 degrees. And remember, we're shooting for an 8-degree target superheat. So the 40 from the 55, that gives you a 15-degree actual superheat. So your superheat is high, so that means you need to add refrigerant. Now, when you're adding refrigerant, you need to let the system stabilize for a minimum of 20 minutes. The longer that system runs, the more stable it's going to get, the better readings you will get on your superheat. So when you add refrigerant, again, it needs to be added. It has to be added as a liquid. The refrigerant cylinder needs to be inverted or turned upside down. Just add refrigerant slowly into the suction line. Make sure the compressor is running. Throttle the manifold open and close. You won't get any refrigerant into the compressor if you do that. It's a very safe way to do it. Add refrigerant in 5% increments. Again, anytime you add refrigerant, you need to let the system get stable again. So you need to let it run for at least 20 minutes and then check your superheat. And if you need to add more refrigerant, do it again. But remember, the closer you get to that target superheat, the less refrigerant that system will need. So, if you started out with 3 pound adding, let it run. You may only have to add a ½ pound the next time. So it's very easy to overcharge systems. So be extremely careful, because it's a lot easier to add refrigerant than to take it out. Okay, so now the system has an expansion valve. And like I said earlier, most of these systems will come with expansion valves. The expansion valve typically is a non-adjustable valve. So that's why it is very important to get the subcooling at design temperatures. So subcooling is on the liquid side of the condensing unit. You get your temperature on the liquid line, and you get your pressure at the liquid service port. Again, go to your temperature pressure chart with 454B. We'll use 300 pounds of pressure, and that equals 100 degrees saturated gas temperature or refrigerant temperature. And the surface temperature was reading 92 degrees. Remember, on this example, we'll use 12 degrees of subcooling as the design subcooling. So you take your 92 from your 100, and that gives you actually 8 degrees of subcooling. So when the subcooling is low, that means you need to add refrigerant. So again, you need to let it stabilize. You need to add liquid refrigerant to the suction side. Again, just throttle your manifold, open and close, take it easy. Let it stabilize, add refrigerant in 5% increments, and subcooling is not as critical as superheat, but you need to be within a couple degrees of design subcooling. If you're over the subcooling, that system will use a lot more energy than it's designed for. So that's why it's best to get within a couple degrees of subcooling. The higher the SEER rating, the lower the subcooling will be because of the surface area on the condenser is a lot larger. The pressures will be a lot lower. So if you're overcharging a high SEER system, at the end of the month, the customer may have the same utility bill as they did with a lower SEER unit. So that's why it is very important to be within a couple degrees of subcooling, high or low. So this is what I just talked about, energy subcooling. You need to maintain the capacity of the system. If you're low on subcooling, you could get flash gas to the expansion valve. Again, if you're high on subcooling, you're just going to use a lot more energy than what the system was designed for. And that will be in the instruction manual, how to properly charge the system. So each manufacturer will have a little different way of charging the system. So make sure the technician understands how to properly charge that system. All right, so evaporator superheat. So why would you check evaporator superheat? This will show you, what's going on with the system. Is the expansion valve, if you have high superheat, is it low on refrigerant? Do you have a restriction in the dryer? Do you have a kinked liquid line? Is the service valve partially closed? Do you have an undersized liquid line? Suction line installation missing. Armaflex on your suction line needs to be good quality, needs to be ran all the way back from the air handler to the condensing unit. Power element has lost its charge on the expansion valve. I'll talk about that on the troubleshooting. A restriction in the valve itself. Does it have contaminants? Does it have moisture? Restricted distributor tubes. Are they contaminated? Do you have moisture in your distributor tubes? Your equalizer line, is it kinked? Is it restricted? That type of stuff will have high superheat on the evaporator side. So if you have low superheat on the evaporator, your system may be overcharged. That will show up in the subcooling. Is the subcooling very high? Your sensing bulb strap. Is the sensing bulb, does it have good contact with the suction line? Is it insulated? Is it low in the right location? Is it at 12 o'clock or is it at 6 o'clock? Again, all this will be in the instruction manual. Restricted airflow. Airflow is a big problem in residential air conditioning, and I'll talk about that in the troubleshooting also. Air filters. Air filters need to be changed regularly, depending on what type of filter is in the system. A dirty coil. Has the air filter been restricted for a long time, and now it's got into the coil, and it's also got into the blower fan, or the vanes. Are they restricted? So, and duct work. All that contributes to poor airflow across the indoor coil. Expansion valve, seat leaking through will give you low superheat. Inefficient compressor will give you low superheat. Expansion valve moisture, of course, dirt in the expansion valve keeping it open will give you low superheat, and oil logging in the evaporator. So this is just some of the reasons why you would have high superheat or low superheat. So that's why you would want to check the evaporator superheat. And this is only done on expansion valve systems. This is not done on fixed orifice or a piston. So where does the technician get the pressures and temperatures? Well, the best place is at the external equalizer line, and the best place is at the sensing bulb. Now, real world, this can be tough to get, especially pressures. So get pressures as close as you can to the expansion valve, and temperatures as close as you can to the expansion valve. Real world versus what really needs to be done sometimes is not feasible. So, and I understand that, and as a technician, and I'm sure that anybody that's worked on systems can appreciate that. But the two best places are the sensing bulb and the external equalizer. Okay, airflow across the indoor coil. Now, for whatever reason, but most technicians think that they should have a 20-degree split across that indoor coil. That's from supply to return air temperature, or delta T is the proper term for it. Now, a 20-degree split across that coil can be achieved, but typically it's different. So example here is, this is just a normal day. You've got a 62-degree wet bulb temperature. You've got a 76-degree return air temperature, and that coil should be around 56-degree air temperature. So that does give you a 20-degree split. But again, in the real world, you don't have these design temperatures all the time. So on a hot, sunny day where it's dry, and you've got a 60-degree wet bulb and an 80-degree dry bulb, that gives you a 57-degree supply air temperature. So now your delta T, or your temperature, splits up to 23. So on these conditions, and the technician is trying to get the 20, he's taking refrigerant out or adding refrigerant, and he'll never get that temperature across. So it depends on design. And on hot, humid days, again, your wet bulb is very high at 72. Your indoor air return is 78. That gives you a 66-degree supply air temperature. And now your temperature split is down to 12 degrees. So that indoor evaporator, that's why they call it air conditioning, is because it is conditioning the air. It is removing the humidity from the air, and it has to do that before the temperature in the space will start to drop. So the higher the humidity, the lower the temperature split across the indoor coil. And if the technician is charging it by 20 degrees split across that coil at the wrong conditions, he will either overcharge it or undercharge it. And again, these are generic charts. Manufacturers have these charts available, and technicians really need to understand what the temperature split should be across the indoor coil at different conditions. All right, so system evacuation now. Pulling a vacuum on the system is very critical, especially on new installation and when you're replacing components. Compound gauges were never designed to be used to measure micron levels. For example, here is on your compound gauge, 29.14 inches of mercury is 20,000 microns, and 29.1 inches of mercury is 200 microns. So that is very difficult to read on a compound gauge. So what you need is a micron gauge. Hopefully you have one now. Micron gauges are very accurate. The digital ones, are very good nowadays. If you still have the analog type and they're working properly, there's nothing wrong with it. Again, they're tools. They need to be taken care of. Keep oil out of the sensors. That's what typically Micron gauges fails, because the oil gets into the sensors. So take care of them, keep them clean, keep them oil free. They'll last a long time, and they'll really help you out on how to properly read micron levels. All right, so in closing here, we'll talk about some troubleshooting. Again, this is a generic chart. I've got two charts. I've got one for fixed metering devices, which we'll start out with here. And we'll use a couple examples of a undercharge system and low evaporator air system. So when they put their gauges on, liquid pressures both will be low. Suction pressure both will be low. Subcooling both will be low. But the big difference is the superheat. Undercharge, you'll have high superheat. Low airflow, you'll have low superheat. So technicians going out, servicing the system or doing their PMs, they throw their gauges on there. They need to check superheat. They need to check subcooling before they add refrigerant or take refrigerant out. Because if a system is undercharged and they add refrigerant, or if the system has low airflow and they add refrigerant because they think it's undercharged, then they'll get liquid refrigerant back to the compressor. And they can tell this by checking the superheat. Again, undercharged, you'll have high superheat. Low airflow, you'll have low superheat. So again, staying with the fixed metering device system, let's talk about a undercharged and low ambient charging. Both your liquid pressures will be low, both suction pressures low. Superheat, both will be high. But subcooling, undercharge will be low, low ambient will be high. I get a lot of tech calls in the spring, and this is the scenario here. They think the system is undercharged, but what it is low ambient conditions, and technicians really need to let the temperature get above 70 degrees stable before they start taking pressures and temperatures on a residential unit. Because if they're out there and they think, again, it's low ambient, they think it's undercharged, they put refrigerant in, when the ambient temperatures start to rise, either they'll get liquid refrigerant back to the compressor, or it'll go off on high head pressure, depending on how much refrigerant they've added to the system. So again, this will all be in the instruction manuals. Depending on manufacturer, they'll have a minimum charging ambient temperatures. So now let's do some troubleshooting with a system that has an expansion valve. And we'll use the overcharged and dirty condenser as the example. So both liquid pressures will be high, suction pressures will be high, subcooling will be high. Big differences in the superheat. Overcharged, you'll have low superheat. Dirty condenser, you'll have high superheat. So again, if the technician just puts these gauges on there and is not checking superheat or subcooling, he could take refrigerant out because he thinks it's overcharged, and all it is a dirty condenser, or vice versa. So now we use undercharged, and the expansion valve sensing bulb has lost its charge. Whether it has rubbed a hole in the capillary tube going to the sensing bulb, or the bulb itself has lost the charge for whatever reason. There's different reasons why the power element has lost its charge, but there's a big difference between undercharged and bulb lost its charge. Liquid pressures both will be low, suction pressures both will be low, superheats both will be high, but subcooling. With an undercharge, you'll have low subcooling, and if your expansion valve sensing bulb has lost a charge, you'll have high subcooling. The suction pressure may even be in a vacuum, depending on valve. So, in closing, that's the troubleshooting. This is our tech-to-tech service, either phone number or email, depending on, if you're on the job site, you can call us. We man this every day, weekends, holidays. So if you, I always say equipment runs great Monday through Friday, 8 to 5, and it always breaks after 5 and on weekends and holidays. So, we understand that. So call the number. Typically after hours, you get a voicemail. Just leave the message and someone will return your call. If you're just sitting around the house and you've got a question and you want to email us at the tech2tech@chemours.com, that's fine. We'll typically answer emails the next day if it comes in after hours, but we will get back with you. Okay, that is the end of the presentation. Let me see. We've got okay, I don't see any questions coming in. If you want to unmute yourself and ask a question, we could do that. I hope I didn't answer everybody's question. Okay, you unmuted yourself. I can hear the background.
Oh, that's just me, Jamie.
Oh, okay.
Yep. Look, it sounds like everybody got all the information they needed to out of this. If you guys have any comments on it, please reach out to Montel Wolcott and let him know he'll reach out to us. And if we need to make any adjustments before this goes out to your techs, just let us know what you'd like to see. Jamie, thank you so much for doing a great job on this today. I really appreciate you guys being able to get this together for us.
Okay.
And if anybody has any questions, they can feel free to reach out to Montel or to myself, Brian Jesse at Myers Supply. We'll be happy to answer any questions.
All right, sounds great. We'll,
if nobody else has anything else to add to it, I guess we'll close her down.
Okay. Thanks, everyone.